Hello. The Earth is massive. Have you ever wondered how much it weighs? You might think it's very complicated or very hard to figure out. But in reality, it isn't. We only need two equations to figure this out. The first one is force. The force of gravity acting upon two objects is, let me get a different color, size, is equivalent to the universal gravitational constant multiplied by the mass of the first object multiplied by the mass of the second object divided by the distance between the two objects squared. You can use any variable for the distance. I'm going to be using r. You can use d, t, or you can use whatever. And then there's the second equation, which is the force acting upon an object near the surface of the Earth is equivalent to the mass of that object multiplied by the acceleration of gravity. So let's start over here. What is this? It looks really weird. Well, this G is equivalent to the following. It is equal to 6.67 times 10 to the power of minus 11 Newton meters squared divided by kilograms squared. I won't go into too much detail on this because I do assume that you know what a Newton is and what acceleration is. But I will go briefly over what the Newton is. The Newton is enough force to, so it is enough force to accelerate, this could work. A 1 kilogram object, at 1 meter per second squared. So basically it's enough 1 Newton is the force required to accelerate a 1 kilogram object by a rate of 1 meter per second. So let's say it's like you just let's say t equals 0, and this is when you haven't applied any force to the ball or the object. And so time equals 0, velocity also equals 0. Let's say 5 seconds go by and you apply this force. So let's just do a dimensional analysis here. So it's meters over seconds squared. You multiply it by 5 seconds. This crosses off, this just becomes seconds, and so you get 5 meters per second. And that is assuming that the force is constant, so 1 Newton, within 5 seconds, the force will be 5 meters. The speed, the velocity will be 5 meters per second. So the acceleration of gravity that is equal to 9.8 times more than this. So the acceleration of gravity on the surface of the Earth is equivalent to 9.8 meters per second squared. Alrighty, I got it. I got rid of the stuff to make room for some space. And now we are going to actually going to do the actual math here. So we are going to make this force equivalent to this force. We're going to set them as equivalent to each other. And by the way, this mass will be mass 1. So mass 1 times the acceleration of gravity near the surface of the Earth is equivalent to the universal gravitational constant multiplied by the mass of that object, mass 1, times the mass, let's call it E for the Earth, and divide it by the distance between the two objects squared. So we just want to get mass E all by itself, isolated by itself. So we divide both sides by the mass of the first object. So we get small g. I'll be calling the acceleration small g. Multiplied by the universal constant of gravity. I'll just be calling that big G. So it's big G times mass of the Earth. I'll call it mass E. And then divide it by distance squared, or let's call it r squared. And so we multiply both sides by the distance r squared, and divide both sides by big G. So we get small g divided by big G and then multiply by r squared is equivalent to mass of the Earth. So let's get out our calculators. And also, I forgot to mention that the distance between the surface of the Earth and the center of the Earth is 6.38 times 10 to the power of 6 meters. So let's just do the simple units here. I'll just put it on the side. Sorry. This will do. Okay. So 6.38 squared, because remember we're doing distance right now. And we multiply it by 9.8, or acceleration. So 9.8, which equals 398.90316. Then we divide it by 6.67, which equals 59.8055. So we're just going to approximate it to 59.8. We also can't remember these units. We already know that the units will just end up as kilograms. You can try it for yourself. So we have 59.8 multiplied by 10 to the power of 12. 10 to the power of 12 divided by 10 to the power of minus 11. So that is just going to be equal to 59.8 times 10 to the power of 23. Or if we want to make this scientific, to put it in scientific notation, 5.98 times 10 to the power of 24. And we can actually check this to see if it's correct. So this is what we got. 5.98 times 10 to the power of 24 kilograms. Let's check if our answer is correct. We will look up mass of the Earth, which is, so let's see. So there's 3 zeros, so starting from there. It's 3, 6, 9, 12, 15, 18, 21, 24, 25. So there are 25 decimal places. Remember, the 5 starts off the first decimal place. So we take 25. So we only have to move over 24 spaces. And the only thing all you have to do that is just multiply by 10 times 10 to the power of 24. So our estimate over here is actually kind of close. It's kind of close. Pretty close. Pretty close. There, 5.98. Here it's 5.9. There's 5.98. Here it's 5.974 times 10 to the power of 24. So we got it pretty accurate. We didn't need any very hard equations. Nothing too complicated or fancy. It's just two equations. Two simple equations. And using only these two simple equations, we could pretty closely estimate the mass of the Earth. And I would like to thank you for watching. See you in the next video.